Hello guys and welcome back to CS with Mr. G. This is our last lesson in Unit 6, Automated and Emerging Technologies. And in this lesson, we are looking at the term artificial intelligence, where we need to explain what artificial intelligence is, what the key characteristics are, and explain what the components are inside of artificial intelligence, looking at some real-world examples and gaining a thorough understanding of how it works and why we will only see more artificial intelligence as we move forward. So we can see here Unit 6 is the final topic of our Paper 1 topics. So all of these topics here, these are all theory. Before we move on to 7, 8, 9 and 10, which are all Paper 2, but this is the last lesson of our theory topics, and a well done if you've made it this far. So our syllabus topics today, as you can see, we need to understand what is meant by the term AI or artificial intelligence. We need to describe the main characteristics of AI, which includes how it collects data and follows certain rules when using this data, and how it can reason like a human can, and also the ability to learn and adapt just like a human also. We also need to explain the operation and components of an AI system, so what's inside of an AI system, and how these work in order to what we call simulate intelligent behavior. So on that term intelligent, if we just take the meaning of intelligence first, being an intelligent human means that you have the ability to learn, understand, cope, or at least try new situations, apply ideas that you already know to different situations, and then the ability to abstract and discover patterns, especially when it comes to data. So all of these terms come under the term natural intelligence, and as long as any one of these terms are mimicked artificially, that would mean something would come under the term artificial intelligence, or as we know, AI. So the term artificial means that it's not natural, it's not a human that's doing it, it's a computer. It's the simulation of the intelligent behavior that we've just spoken about, but performed by some kind of device, some kind of robot, some kind of computer. And as you can see in the image, you've got our phones, cars, anything that has a processor inside. As long as it can perform any of these abilities, that means we could call it AI. So there are 4 key characteristics that we need to understand that define artificial intelligence, with the first one being the collection of data. And AI systems are designed to gather and process data in some way. This can be anything from images, sounds, numbers, and obviously text. And then what they will do is they will follow certain rules using this data in order to make decisions or even solve problems. So these rules that I'm talking about, they could obviously be programmed by a human or even discovered by AI itself. And we will go through some examples of some basic rules later on in the lesson. The ability to reason is another way of us saying that it has the ability to think. Believe it or not, computers do not think for themselves. They are programmed to do so. Although, as we've seen in the last couple of years and the boom in the AI industry, it does feel more and more like they are able to think for themselves. But something that I'm trying to teach you in this lesson is that they aren't thinking for themselves. They are what we call reasoning by following the rules that they are programmed to do and combining it with the data that they have in order to appear like they are thinking. And then finally, the ability to learn or adapt means that they get better and better over time, learning from their experiences. And this is what we would call a term that you might have heard, machine learning. So this is where AI has really accelerated in the last couple of years with their ability to learn and adapt. And an easy to understand example to show its ability to learn would be the autocorrect system on your phone. The more and more that you type on your phone and the phone starts to learn how you write or certain things that you might say, over time, the autocorrect feature will get used to this and it might stop offering spelling suggestions on a word that you might spell a certain way. But again, this ability to learn or adapt is a key characteristic of AI, and these 4 characteristics are what we are expected to know for our exam. So as we've mentioned, the collection of data being the first characteristic we looked at, and if we just use ChatGPT or any other chatbot as an example, so Copilot or Gemini or any other AI model similar to these services, if we think about how many people use them daily and how much data they are able to gather, the more and more data that they collect will allow them to get better at making decisions as we move forward in time. But this collection of data is what we consider a characteristic of AI itself, because without it, it wouldn't be able to follow the further characteristics, such as making decisions or learning and adapting. But this data, as I've said, can be numbers, text, images, or even sounds. And once AI has this data, we go back to this word algorithm, following a set of rules in order to make decisions or solve problems that we give it. So if you think about it, one of the first things that these chatbots would have done is scrape the internet for as much data that I possibly could so that when people came to use it, there was some kind of data that it had to work with. If we went to ChatGPT and asked it, what's the weather going to be like today? It would have had to have collected data from somewhere in order for it to give us an answer. So as I keep saying, the more time that passes by, the more people that use these AI systems, the better it's going to get, the more data that it will have, and the decision-making process and the problem-solving will only increase in performance. Next, we have rules or algorithms, and rules are used in order to answer questions and again solve problems. As I've mentioned, they can be manually programmed by us, or using machine learning, they can discover the answers themselves. A very easy to understand example is giving an AI model a set of rules that determines if a photo shows a cat or an elephant. Obviously, a cat has specific elements such as pointy ears, patterns on its fur, eye shape, facial structure. Now, all of these things we would program into the AI model, give the AI model a photograph, and tell it if it was right or wrong on its decision if it was a cat or not. So the more photos of cats that we give it, and the more times we tell it if it's right or wrong, the better it will get at identifying photos of cats. And what seems like a very basic model is how AI is built. Again, if we think back to ChatGPT, the more times we tell it it gave us a good response or a bad response, the better it will get at telling people in the future the answers to questions or solving problems that we give it. So again, just to confirm, this collection of data, the rules that we give it, are two fundamental characteristics of AI that have allowed it to become so powerful in today's world. Next, we had this term reasoning, and I mentioned that this is what we could call the ability to think. Now, what this term thinking means is the ability to make decisions or predictions, again, based on the data that it's collected and the rules and algorithms it's programmed to follow. So thinking through a problem and coming up with a solution based on what it knows is what we consider the ability to reason. Playing a game of chess against the computer, where the computer will think ahead, consider the possible options that it could make. This is something that we would consider the ability to reason in terms of AI. And next, we had the ability to learn and adapt. And I mentioned the autocorrect feature built into phones. It will learn from words that you use most often, make suggestions based on what it knows about you. But this is just one example. Another example could be many video games that learn from the way that you play. Take FIFA, for example. If you're playing a game of FIFA and you're able to win games by 20 goals or more, the AI model might recognize this and think, okay, this is too easy for you. Let's make it a little bit harder. But just remember, this ability to learn and adapt is what we consider machine learning. This is our key definition that we need to remember, and one of the terms that the mark scheme would be looking for when we are looking at the key characteristics of AI. Next, we need to look at what is inside an AI system, and these 6 items here we will go through. Won't take too long, but what's important is that we can remember these 6 steps and explain what's going on at each point in an AI system. So firstly, this term input data. We've mentioned data quite a lot this lesson, but without it, an AI system will be useless. So this is the first component we need to understand in terms of collecting data, or even when it's got the data and we give it some kind of query or question, we input more data in order to use the AI system. Next, we have the rules or the instructions that AI has in order to process the data. If we go back to our cat example, these algorithms will be the instructions on how to recognize a cat. It will take our input data, it will take the photo, it would follow the rules and try and give the best possible answer based on these algorithms. But the term algorithm is something we've discussed a lot in this course. And remember, they are just instructions that a computer follows, or if we think of it as a recipe that AI has in order to solve problems. This term again, machine learning, and a crucial feature of machine learning is the ability to recognize patterns and make predictions. We've mentioned the autocorrect feature on our phones. Another great example that I use in my lessons is the facial recognition in photos. If you've used any modern photo app, such as Photos on Apple or even Google Photos, if you've got a collection of photographs with lots of different faces in it, you can tell your device who is in the picture, and over time, if the device recognizes this face in future photographs, it can determine who it is, label the photograph with this person in, and be able to sort your photographs based on this person's face. So you can see here in this example, it recognizes this face as a certain person, and you can filter out this face in your photo album if you just wanted to find photographs of this person. But again, it falls under the category of machine learning as it takes the data, it recognizes the patterns, and we can give it feedback. For example, if it incorrectly identified a face as somebody else, we would tell the device that it was wrong, and it would learn from its mistake and it wouldn't do it again. Data processing pretty much speaks for itself. Once it's got our input data, ran through the algorithms, it will then process the data and think about what it's going to do next. So we just go back to the photograph example. Once you take a photograph on your phone, the pixels in the picture, the data itself from the image is processed using these algorithms and reasoning, and the device will start to come up with some kind of answer and determine who was in the picture, for example. And that's where the term output comes in. So once it's determined who it was, it will tell you that it's this person, but it will give you some kind of output or answer to the question. And in our case, it will tell you who is in the photograph. Another example could be to recommend a movie based on movies that you like. And you could input the data. Again, you could input a movie name. It would follow the algorithms, look at what genre the movie is, look at the actors who are in the movie. It would process the data. It would follow these steps, and it would give you some kind of answer to that suggestion. If you take Netflix, for example, the input data would be you selecting films and watching certain TV shows. Once Netflix builds this portfolio of films that you like and stores the data about you, it will then start to determine future recommendations, again, based on the data that it has and the algorithms and rules that it follows. And finally, we give it some kind of feedback. In the photograph example, we could say that it was incorrect. We could tell the device who was actually in the photograph. If it recommends a film that we don't like, we would tell it and it wouldn't recommend that film again. But again, we tell it if it worked or not, and it will get better based on this feedback. And of course, keep this data stored within its system. And finally, we just need to go over this term expert system. And an expert system is a type of AI which uses everything we've talked about in this lesson, but would typically exist in a specific area or some sort of field of work. So the term expert system is some kind of system that would replace what we would consider a human expert. So if we take some human experts in real life, if you think about in the health industry, we would consider a doctor as an expert. In the food industry, you would consider a chef as an expert. You would consider a mechanic an expert when it comes to cars. So any of these experts that we're talking about is replaced by a system. It would definitely need to use AI in order to be successful. Now, there is some technical terminology that we need to recall when it comes to an expert system, and we need to explain what they consist of, which are these four components here. We have a knowledge and a rule base. We have an inference engine, and lastly, some kind of interface. These tie in nicely with everything that we've talked about so far. And then the interface is easy to understand, and we'll come to that in a minute. But firstly, the knowledge base, and this is exactly what we've been speaking about so far, the collection of data, a library of knowledge in a specific subject. If we take a medical expert system, for example, the knowledge base would contain information about certain diseases, the symptoms of any conditions, how we treat those conditions, and just an abundance of medical terms that would obviously serve a purpose and help this system make decisions just like a doctor would. So if you think about it, a doctor that goes to university for many years and acquires a whole load of knowledge in the medical industry, an expert system would contain this same data, but it would just be stored digitally as opposed to in somebody's brain. The rule base ties in nicely with what we considered as reasoning or the algorithms. So the rule base is just a collection of if statements where if something is true, we'll do this. If something else is true, it will do that. And an example here could be if a patient has a sore throat and a fever, then it could possibly be a throat infection. And now if we just go back to this diagram here, as we can see, the knowledge base and the rule base kind of tie in together, and they both plug their information into the inference engine, and it will tie the knowledge base and the rule base together in order to make decisions, or like we keep saying, solve problems. So we can consider it the decision maker of the system, and it will use the information from the knowledge base and the rule base, apply that to any data that's been input until it comes to some kind of decision or answer for the user. So in the example with the sore throat and the fever, it could keep asking questions in order to acquire a bit more information. It would follow some more algorithms from the rule base until it found its best possible answer, which it would then give back to the user. And how it would give it back to the user would be using some kind of interface. So the three components we've looked at, they all live behind what we would call an interface. So an interface we've looked at in Unit 4, and us as humans, we want something to look at, something to interact with in a nice and easy to use way. So if we just stick with the medical expert system and we had some kind of app or website, such as this one here, we can put our query or our symptoms into this system. It would use those three components in the background and would give us recommendations based on what we told it. And all of this appears nice and easy to use using what we call an interface. in order for us as humans to interact with. So as you can imagine, an expert system is only going to be as good as the knowledge that it has. So it's a good idea that experts would make these systems, and they would need to be built on reliable and reputable knowledge. Now, if we just think of any AI model that we've spoke about in this lesson, ChatGPT, Copilot, any of these services, these are what we could consider an expert system in pretty much all walks of life. Expert systems were originally designed to only exist in one field of work, for example, the medical industry. But ChatGPT, we can pretty much throw anything at it and it will give us some kind of response in order to solve our problem. If you think about car mechanics, fixing things with a computer, we can pretty much throw anything we want at ChatGPT now, and it tends to give us reasonable answers. So these key terms, guys, please be mindful of them. They can pop up in exams, but hopefully the understanding of AI and what it's built of, you've been able to understand in this lesson. So just to finish off, if you just fill in these gaps with the keywords from the bottom, and first and foremost, AI stands for, as we know, artificial intelligence. So number one, we'd put there. The main characteristics include the collection of data and rules, the ability to reason, and the ability to learn and adapt. Expert systems are one use of AI. Another technique is machine learning. Here, training data is given to a computer, which then creates its own rules. So the example of the cat, we would give it loads of images of a cat and tell if it was right or wrong. And this is what we would consider training data. And that concludes our lesson. So as always, guys, I hope you've managed to follow along. This is only a small unit in Unit 6. And like I've mentioned, it's the last unit within the theory aspect of the course before we move on to the Paper 2 topics, which is all about programming and problem solving. Any questions, please drop a comment in the section below. And hopefully I'll see you in Unit 7, where we will look at problem solving and start our journey into programming. Thank you for watching, and hopefully I will see you there.